This video provides an overview of procedures that may help if a calibration does not restore cut accuracy for a twin-axis sheathing saw, including modifying the counts per inch value. Always follow all posted safety instructions. Perform any lockout/tagout procedures according to your company's guidelines, and always review all documentation before operating any equipment. Sometimes you may still experience inaccurate cuts after performing a calibration. This may happen due to a new saw or a first-time calibration, any mechanical maintenance or changes to the conveyor system, loss of software configuration, which can happen if a factory reset is performed, a new computer is installed, a new user is added, or the configuration becomes corrupt. Verifying some mechanical items is a good first step to restore accuracy. Fine-tuning the counts per inch value can also help restore accuracy if calibration does not and no mechanical issues are found. Before performing a calibration, check the tension on the conveyor chain. The conveyor chain runs the entire length of the machine on the non-operator side. See the twin-axis sheathing saw manual for more information on adjusting the conveyor chain tension. Also check the encoder for damage or signs of slippage. Configuring a new counts per inch value can help restore accuracy if the calibration does not and no mechanical issues are found. The counts per inch value is configured in the task software. To determine what the new counts per inch value should be, a calculation is used. The calculation is currently displayed. CPI is the currently configured counts per inch value. The actual cut value is the configured cross-cut value, and the target cut value is the cross-cut measurement was after the inaccurate cut. There is a counts per inch calculation worksheet available to aid in applying the calculation. The worksheet will be referenced later in this procedure and is available on the MiTek website. We can start by determining the actual cut value and target cut value. To find the target cut value, start by using the same material you calibrated with and noticed inaccurate cuts on. For this example, we will use an 8-foot sheet of OSB. Load the board onto the in-feed. From the home screen, select the Semi-Auto button. For our example, we will select OSB as the material type, then configure a cut with a 6-inch rip width, 3-inch crosscut, and a 90-inch crosscut. The actual cut value is the configured crosscut value and what the cut measurement is compared to for accuracy. The value in this example would be 90. Select Start Cycle to process the material. Measure the 90-inch crosscut, recording the results. Turn the material to the in-feed and process it 2 more times using the same cut parameters with the semi-auto function. Again, measure the crosscut, then record the results. Compare the 3 results to see if they are identical. If the results are identical, use this figure as the target cut value. For this example, the value is 90.125. Note, if the cuts are inaccurate to what was configured but not identical to one another, there is likely an issue with the encoder, such as slipping, or the chain, such as wear or improper tension. See mechanical troubleshooting from earlier in this procedure for more information. To find the current counts per inch value, start by navigating to the C drive on the computer. Open the File Explorer, navigate to C drive and open it. Open the Users folder, then open the folder of the logged-in user. Open App Data folder. Open Local. Then navigate to and open Twin Axis. At the top of the File Explorer, click on the small arrow drop-down next to Type and select JSON. This will display only the JSON files. Creating a backup before modifying any of these files is highly recommended. To create a backup, create a folder on the desktop named Configs and today's date. Copy all of the JSON files in the Twin Axis app folder to the folder you created on the desktop. After creating a backup, navigate back to the Twin Axis app folder and open the materials JSON file. Look for the material type you calibrated with and performed the 3 test cuts on. For all 3 material types, there is a conveyor counts per inch value as seen here. Note the value next to your material type. In our example, we are using OSB. Now that we have all the necessary values, we can use the equation to find the new counts per inch value. For this example, we will be using the counts per inch calculation worksheet. In the yellow box marked A, input the currently configured counts per inch value. For this example, this value is 1001.971. Next are the actual cut value and the target cut values, both found in step 1. Both values are entered in inches. In the blue box marked B, input the actual cut value. For this example, the value is 90. In the red box marked C, input the target cut value. For this example, the value is 90.125. The new counts per inch value should populate in the green box, marked D. For this example, the value is 1000.579. Navigate back to the materials JSON file, as described in Step 2, and open it. Find the conveyor count per inch value in the file for OSB, or whatever your material type is, as before. Replace the current numeric value with the value marked D, or calculated counts per inch, from the counts per inch calculation worksheet. In this example, the new counts per inch value is 1000.579. It is critical that there are not any extra spaces or any other modifications in this file other than replacing the conveyor count per inch value. Once replaced, close the Notepad program. When prompted to save, select Save. Perform an identical cut on the same material as used in Step 1. As before, measure the crosscut for accuracy. If the cut is still not accurate, follow Steps 1 to 4 to configure a new counts per inch value again, or contact automation support. If you have any questions or need further assistance, please contact automation support.